I'm Martin Hill, and I am the Acting Head of the Department of Electrical and Electronic Engineering in CIT MTU. In our department, we currently have 4 programs: a Level 7 program in Electrical Engineering and a Level 7 program in Electronic Engineering. These are 3-year programs. We have a Level 8 program in Electrical Engineering and a Level 8 program in Electronic Engineering, and these are both 4-year programs. Graduates of our Level 7 programs can continue into the 4th year of the Level 8 program to have a Level 8 qualification, and this is very common in our department. So what do engineers do? Engineers are the inventors and problem solvers of this world. We do this using science, technology, and maths to make things that benefit society. As well as having technical skills, engineers also need to be creative problem solvers and to be able to explain the benefits and challenges of their work to the public. At times, engineers will work alone, but more often they are part of teams bringing together a range of expertise to solve complex problems. Take a laptop as a great example of how multiple engineering disciplines work together to produce a useful product. Mechanical and industrial engineers design the case and assembly. Electrical and electronic engineers design the processors, supporting circuits, and program these devices. They then work with manufacturing engineers to economically produce large numbers of machines. Electrical and electronics graduates have much in common. They both work with electrical circuits. The difference between them is in the scale of the projects on which they work. Electrical engineers are concerned mainly with large-scale production and distribution of electrical power. Think of wind turbines, the electricity grid, and big industrial and commercial installations where electricity is used. On the other hand, electronic engineers focus on much smaller circuits, like those in PCs, smartphones, and smartwatches. These are generally low-power, programmable devices that often use data communication and include many layers of software. In CIT MTU, we offer Level 7 and Level 8 programs in electronic engineering. These programs focus on electronic systems that collect, process, and transmit information. These systems that are found everywhere from heavy industry to cars, household appliances, healthcare, and smartphones all have one thing in common: they're intelligent. At the core of intelligent modern electronics is the microprocessor. You might know what processor is in a Sony PS5. It's an AMD Zen 2 with 8 cores. Or in your laptop, you probably have an Intel Core i5 or i7. The processor executes instructions from the program it is running, called the system software. And almost everything we use today, from children's toys to your smartphone, use a range of embedded processors. A new car is a good place to see how much we now depend on microprocessors and electronic systems. If you were lucky enough to own the top-of-the-range 7 Series BMW, it would include about 100 processors. The processors are squeezed into the side and rear view mirrors for blind spots, into the seat headrest for safety, comfort, and an integrated monitor, the engine management unit to improve fuel economy, bumpers to avoid collisions, and in the modern dashboard for the radio, air conditioning, and GPS system. I want to emphasize that this is in a current model and not in the electric or self-driving cars of the future. They will have far more processors, data connectivity, and intelligence. I could equally give examples of systems in health, like rapid COVID-19 testing, environment or industry, where electronic engineers work. They're involved in designing, producing, and programming the components and systems that enable us to live our modern lives. As they serve all sorts of applications, our electronics graduates work in a wide range of companies. They design electronic systems with companies like Intel, who are currently investing €7 billion in Ireland, and closer to home, in Dell in Ovens and Ballincollig. In Costal in Mallow and Abbeyfeale, they develop embedded computing systems as described above for major car manufacturers. They also make similar systems in less obvious places like Boston Scientific in Cork and Clonmel. Mobile communications companies like Qualcomm and Macom also recruit our graduates. There are few places where our electronic engineering graduates are not sought after. Our department also offers Level 7 and Level 8 programs in electrical engineering. The programs focus on the generation, distribution, and use of electrical power, and on process automation and control, as the devices being controlled are often large electrical loads. In the program, there is an emphasis on the cost, safety, efficiency, and carbon footprint of the electrical network on which we all depend. Like our electronics graduates, our electrical graduates are employed across a wide range of companies and sectors. In power generation, they work with GE Energy and SSE Airtricity in wind generation. One of our graduates has his own startup, PV Generation, designing and installing domestic and commercial solar power systems. Many are also recruited by EirGrid and ESB networks. On the electrical load side, our students work on the design and development of electrical installations for buildings and factories with project management, Jacobs and Dornan Engineering. With our strong emphasis on automation and control, our graduates also work for Liebherr in Killarney, who design cargo cranes for ports worldwide, and in many process industries like Pfizer. Engineers use science, mainly physics and a little chemistry, and maths to make things that are useful to society. I'm often asked, is there a lot of maths in the course? Unfortunately, the answer is yes, there is. You will do a lot of maths in any engineering course. Hopefully, the maths will make sense as you are using it for some practical application. You don't have to have honours maths, but if you dislike maths, then engineering is probably not a good choice for you. If you do have an interest in how things work, the course will develop skills to make you a good problem solver. You must be able to identify problems, come up with possible solutions, and critically evaluate each solution to determine which one has the best chance of working. That's what engineers do and where they get the most job satisfaction. This systematic approach to solving problems is also valued by many industries, and many engineering graduates end up working in management, both in engineering and non-engineering companies. If you think that you fit the description of an engineer above, then I guess the next question is, why CIT MTU? We believe in a hands-on learning approach to engineering. All our students spend at least half their time in practical and project work, and many assessments are practical-based. Our students work on team and individual projects every year in their program, and they have a work placement from March to September in their third year. Student feedback has been very positive on this approach, and most of our students enjoy the time spent in practical learning. Employers also tell us that they value the practical ability of our graduates. Finally, I want to conclude by explaining what makes engineering a worthwhile career option and what the future holds for graduates of our program. The great global challenges at present are outlined in the UN's Sustainable Development Goals, which include an end to world hunger, affordable and clean energy, combating climate change, responsible consumption and production, good health and well-being, and sustainable cities and communities. Society needs to engineer solutions to meet those challenges, and that depends on young people committing to the profession. In my area, electrical energy and networked electronic devices will be at the heart of our sustainable future. We already have 30% of our electricity here in Ireland produced from renewable resources. The target for 2030 is to have 70% renewable electricity production. That requires a massive investment in wind and solar electricity farms, a smart distribution electricity network that will manage how we use energy so we consume most when there is lots of solar or wind energy available, and interconnection to European electricity grids. EirGrid is currently working on an interconnector to France that will allow 700 megawatts of electricity to move between the countries, and that's enough to supply around 450,000 homes. To reduce greenhouse gas emissions, renewable electrical power is going to become our dominant power source. As well as its current uses, it is planned that almost 1 million electric cars will be on Irish roads by 2030. And all new and retrofit homes and buildings will replace oil and gas boilers with much more efficient electrical heat pumps. The work required to deliver these essential changes in how we live will ensure that electrical and electronic engineers will be busy working on exciting projects to meet the needs of society far into this century. Whatever course of study interests you, if we in CIT MTU can help you to make your decision, please feel free to contact us. I wish you the best whatever CAO option you select, and if you do come to electrical and electronic engineering in CIT MTU, I look forward to working with you.